Okay, so this week or this day of the week, we are talking about tsunami. These are going to be our large waves that we can see after three different types of hazards, and we'll actually talk about those throughout the slideshow today, but typically with our earthquakes. All right, so the first thing to know is that tsunami is both the singular and the plural. So if you choose to cover an earthquake or you choose to cover a tsunami for your profile that's due at the end of the 4 weeks, make sure you're not writing tsunamis with an S on the end. It is just tsunami. It's a Japanese word, so it's just how it is, tsunami. Plural, singular, both. So the thing to think about is it is a really large set of waves. And so it's not like a traditional tidal wave like we think of here in the United States. So a lot of times we'll hear the term tidal wave. That's not what we're looking at. A true tidal wave is singular wave. That's kind of an abnormal in terms of wave height that we will see. Tsunami are going to be a series of waves. And basically it's like an entire sheet of water moving over into an area. And here's a picture, and you can kind of see that idea with the image here from the Japanese tsunami that occurred in 2011. But they are very, very large, very long in terms of how large this wave is. It's not like that cartoon where you just see this like giant tall wave. And it's going to be caused by any type of oceanic disturbance. And we can have that happen a couple of different ways: earthquakes, volcanic eruptions, landslides, volcanic collapses, anything that's basically going to help displace water is going to potentially lead to a tsunami situation. So the big thing here, and it says there, water is not compressible. You know this. You can only fit so much water into a container. You can't overfill a container without it overflowing. And so what's happening here with our tsunami is that we are displacing water just like you do if you get in a bathtub, a hot tub, a swimming pool, whatever it may be, or you put an ice cube into a drink, right? That water is not compressible, so the height of the water actually increases. That's what happens here with our tsunami, is that somehow we are either adding mass into our water body, or we're changing where that mass is and how it looks. So in this image with our tsunami, basically, we're looking at an earthquake situation where we had part of our plate boundary rebound, and as it pushed up, all of the water on top of it also pushes up. If we have a volcanic collapse or landslide, and again, we'll talk about these here in the next few minutes, we're taking where our mass was and moving it, and as we move it, that's going to displace some of that water. Okay. Typically, when we're looking at earthquakes, we're going to look at it in terms of a subduction zone. So with our subduction zone, remember, that is when we have two plates that are running into each other. Specifically, in this case, we have one plate that's sliding under another. We will not see tsunami be a risk or occur when we don't have this vertical change within our plate boundary or our crust that we are dealing with. Okay. The other thing that we see in terms of characteristic is that there's really not a good equation or model for how soon after an earthquake would occur that we would see the first of the wave come on to the shore. And so really a lot of places are basing their education on, if you feel an earthquake, if it's an earthquake caused tsunami, that you'll get to higher ground immediately, because what tends to happen is the first wave is not the highest. And in some cases, the time between the individual waves coming to shore can be upwards of an hour. And so it's really not a great idea, if you find yourself in this situation, to think the first wave came through and now everything is fine, especially if you're waiting a long time, because that period between waves can be very, very long. Okay, so let's look a little more in depth in terms of earthquake cost. And we have this great image here on the right where we see our plate on the left is subducting under our overriding plate. Notice that it starts to pull that overriding plate backwards. I really like to think of this as the old Gillette razor commercials where they would show like the animated hair that was up in the air, and then the razor would come back, and they would say how much better their razors were because they left less hair to pop back up at the end. If you've seen the commercial, you know what I'm talking about. If you haven't, I swear I'm not crazy. Google it or YouTube and you'll find it. But notice in our third image here, what happens a lot of times when we release that stress is we get snapback. And so if you look between image B and image C, you can see where that overriding plate edge difference is. Okay, and so with that, we get that vertical change. It pops the water up as that land springs up underneath it. Now, what we'll notice on the beach end of this, or our coastal end of this, is we'll see a pullback of water. So we'll physically draw back as it's pushed upward. So this is one of those signs that if you're ever vacationing somewhere, whatever it may be, because this really can save lives for people that are educated, that if you start to see this like very strong retreat of water, you need to get inland and up in elevation as quickly as possible, because that is a very clear sign that a set of tsunami waves are coming your direction. So just keep that in mind in case you ever find yourself traveling. We will only see, again, this type of event after an earthquake if there's vertical plate movement. So what that means is when we have seafloor spreading, because that's happening only on the horizontal, we won't get a tsunami as a risk. If we see a strike slip situation where we have that horizontal movement of plates sliding past each other, we won't run the risk of a tsunami. If we have continental buildings, so two continental plates running into each other, again, we're not going to see this risk. So we do only see this risk typically when we have convergent plate boundaries and, more importantly, subduction zones over a body of water. We're going to typically really talk more about tsunami in terms of ocean situations, but that's not to mean with our other two causes, the volcanoes and landslides that we're going to talk about in the next two slides, we couldn't see this happen within a lake or another closed body of water. It can certainly happen. With earthquakes, typically we need a 7.5 magnitude or higher. That means there's enough energy release that we get a pretty good snapback. However, if we're looking at like low-lying, just above sea level islands, and we certainly have them out there, they're like 2 to 4 feet above sea level, there could be enough movement that we would certainly be worried, not necessarily of super tall height in terms of our wave, but certainly enough that we could be running the risk of flooding, or, you know, if water moves fast enough, even if it's very shallow, it can start pulling things and could certainly get people off their feet and certainly get materials dragged back out into the body of water. When we look at volcanoes, we're typically looking at two things here. Some kind of volcanic material is moving down into water, whether that's actually lava or magma or pyroclastic material, if it moves fast enough, or we're looking at basically a lot of times we'll have a collapse. So part of the volcanic structure itself will collapse, or we could blow out the side of it during an eruption, and that can put enough material into our water body, and this could be something that we can see, or it could be something that happens all below the surface of the water that we are not seeing. Again, what we're looking for here is enough material to displace that water, so that basically we're getting that idea in all situations where we're dropping a rock into water and we get those concentric circles of energy to move outward from that spot. It will go towards the coast, wherever the coast may be, and out into the open ocean. With landslides, we're looking at gravity pulling down rock and sediment into the water. We'll talk, mass movement will be our last lecture, our last topic. We'll stay of week 4, so we will get into more detail about this. But basically, again, we could have material fall from outside of the water down into the water, or it could be a subsea landslide where everything's happening below the surface. Okay, again, and I said it now on the last slide, and they're very similar in this case, we are looking for displacing water. So, you know, it's like putting that ice cube into the water, or you getting into the bathtub or hot tub or pool, whatever it may be, whatever example works for you. You know, we are, once we start taking up space, water's not compressible, so that water is going to react as a result. Okay. A lot of times landslides are not going to be a major concern for tsunami because a lot of mass movement is slower or not to the extent in which we're going to have enough material to really displace water to get a tsunami that's very, very large or has a lot of energy generation. So we don't see this super commonly. However, we could see something on a smaller scale and possibly only moving out to sea. And this is when we could see it happen in a closed body of water. So there's really nothing to say about, our cliff style kind of geography or topography that may be along Lake Michigan to see if we had a fairly good landslide movement, that we wouldn't get a series of waves that would then move from that point outward into Lake Michigan. So it can certainly happen when we have that. But again, we'll talk more about landslides individually and the idea of mass movement in week 4. But here I just wanted to go over those 3 different ways that we can have tsunami form. Again, earthquake is going to be the most common. In your text, they give you examples of each of these. So earthquake caused tsunami, volcanic collapse, tsunami, and then landslide type tsunami as well. So we can see all 3 of them certainly, but again, earthquake is going to be your most common.